I've mentioned in the past that while my 286 motherboard has an onboard SD card reader, I would like to have some other form of storage available. And one of the things that I thought would be nice to maybe learn a little bit about is IDE. So how can I connect an IDE drive to my 286 system? And part of that might be something as simple as a compact flash card, or maybe an actual IDE drive, for example, a little laptop hard drive or something like that. What I'm looking at here is an article from PJRC, and they're using an 8051 board, and that's an Intel processor, and I'm not real familiar with it, but if I go take a look at that, basically it's an 8-bit processor that has a little bit of built-in RAM and ROM and a UART, and basically it's meant, I think, really for embedded type of application development, embedded development, and that's what they're showing up here in this article on Wikipedia. And that's maybe not so important because I'm not going to be using an 8051. But what they do leverage besides the 8051 is a PPI, so a programmable peripheral interface. And they show how that basically connects up. And just as a reminder, that's an 8255, or if you have the CMOS version, it's an 82C55. And I'm using that on my 286 board, to control the LCD, to handle keyboard input, those types of things. And here they're showing that I could take an 82C55 and use the 3 ports on it, along with a couple other signals I have to set, but basically manage a 40-pin IDE here. I thought that's pretty handy, and maybe I could try that out. They've given this basic schematic, and I'll zoom into that a little bit, but basically just using these 24 pins off of those 3 ports. 5 of those pins are inverted. They're routing them accordingly over to this. They're pulling one line down to ground. They've got a whole bunch of lines over here pulled down to ground. There's an LED coming into this so that when there's activity, this LED will light up. That all seems pretty basic, and I thought I should be able to implement something like that. So that, along with another page I found where this is for a Z80, but basically it's an IDE hard drive module, and they show the schematic for that. And it looks fairly comparable. So they're, again, using an 82C55. They're taking those 3 ports, and those 3 ports are used to basically control the drive. So what my plan is to build an ISA card that has 2 IDE connectors. And if I pull up my schematic tool here real quick, this is what I've laid out. So I have my 16-bit ISA card edge. So it's a slot, an edge that I can plug into my ISA slot. I then come over here and I have a hex inverter so that I can invert some signals that are coming off of the PPI that will go to the IDE connector. The signals for DMA in these samples, they don't appear to be really using them. They're just pulling, one of the schematics is pulling it up, pulling DMAC up and DMARC down. And so that's telling me they're probably not using DMA, so no DMA support. And my understanding is most of these compact flash cards don't support DMA unless they are specifically labeled as supporting DMA. And I'm guessing the cards that I'm pulling out of a drawer of old stuff I have probably do not support DMA. But regardless, my intention is that I won't have DMA support for these compact flash cards. So it's a little bit slower type of a connection then. I have my PPI here. You can see that I'm connecting in, the IO read and write signals, the reset signal. There's a signal whether or not this PPI should be enabled. And then I have address 2 and address 1 coming into these 2 addressing pins so that I can access the different registers on this PPI. And as a reminder, on my 286 board, I have that PPI. I'm driving an LCD with it. I have another PPI. I'm pulling PS2 keyboard in through it. I have my little speaker on board, speaker that's also being driven off of a PPI. So, using a PPI seems pretty straightforward at this point for me because I've worked with those enough to at least make them work, and I'm not too worried about this here. I did then duplicate all of that, and I have a second PPI and a second 40-pin IDE connector, and that will then let me really run two devices off of this card that I'm building. And then the other thing I have down here is what IO address. And so I'm going to do all of this access to the PPI through IO. So it's not memory mapped, it's IO reads and writes. And that means I need an IO address, and I have 4 jumpers that let me select between 16 different addresses, base addresses. And then within the base address, there is a secondary. So I'm going to use D0 as the standard address here. So I'll set my jumpers 1100, and that would tell it that this card should respond if I try to do an IO read or write to D0 or D8. And basically what I've done is I've used A3 to be the pin that selects one or the other. And so I'm checking the address just to make sure I'm in this D0 range. And if so, then I have a flag here that says, yeah, the PPI, one of the PPI should be enabled. And then I use A3 to determine which specific PPI is enabled. And then I enable those PPIs accordingly. So if I come up here, you can see that I have a PPI 1 enabled, or I have a PPI 0 enable up here. Sorry, PPI 0. So PPI 0 and PPI 1. And then my IO reads and writes go right to this. And that should be about it. I should have logic to do my IO address decoding, enable one or the other of these chips. They're essentially plugging directly into my ISA bus through the ISA slot. And that's going to pull data directly from here. So I have my 8 data lines. I am treating these as an 8-bit PPI because that's really what they are. They're really not a 16-bit, and I'm not going to try to pair these up and read 2 parts of the drive. I'm not going to try to read 2 bytes off the drive and put it into a word or a double byte to put back onto the bus. I'm just going to treat this as a simple 8-bit type of IO, and that's fine for now. So that's what this is, and then if I go look, this is what the photo view looks like. So a really simple card here, and maybe a couple more comments about this. I did leave space, and what I've left space for is to be able to come over here, and I have one of these adapters in hand. So this will rotate it 90 degrees to the right, but basically that will just sit on top of here. I'll have just a small ribbon cable that'll just jumper from my card to this, consider it a little daughter card, or I could just desolder, take this out, and just solder it right onto this header if I wanted to. But being that I'm really just trying to learn and experiment here, I didn't want to have some permanent mount thing here. So this is a header that I can go out through a ribbon cable to some device, or I can put some device right here and just try to connect it with a short little ribbon cable. Or even put something on the back side of the card if I wanted to and run the ribbon cable to it. But this is what I'm going to use. So this will connect into my card, and then a CF card will plug into this here. And it looks like there's a power light and activity light and things like that. Also, this is where I can bring in power. And for the CF card, I think all I need is a 5 volt, so that's easy to work with. And it looks like here I can specify, that I want to use a 5 volt external, and then I'll bring 5 volts into the appropriate pins here. And so on this, I made room for those. I made a header that I can then pull power and run it into those 5 volt connectors. Basically I don't know what those connectors are actually called. They're the old school floppy drive type of connectors, whatever the name of these are. But I think I can either just connect into what I need to for pins, or desolder that and run my own connector down to one of these. The nice thing about this card too is because I have it selectable on what I/O address. My sound card is doing something similar, and it can select one of the 16 addresses available. I could put in one of these cards and use up another one of those 16 addresses, and that still leaves me 14 more addresses. So if I want to put in a second one of these cards on a different address, or a third or a fourth, I can do that. And if I want to just use these PPIs for some other type of I/O, this doesn't have to be IDE, I can just use the appropriate set of 8 pins for each of the ports. So there's 24 of these pins that go straight to the ports on the PPIs. So if I want to make let's say a joystick type of I/O, I can do that. I would just connect my pins accordingly. And I have plenty of room on here to slap on different daughter cards and try different things. So just kind of a universal add a pair of PPIs to my system very easily by just plugging it into an ISA slot. But the first purpose here is to use it as an IDE controller for a compact flash card, or maybe a pair of compact flash cards. So we'll see how that works out. But that is what I have. Now probably the hardest part, if I got the wiring right, which is always a question when I do these. I didn't put a lot of time into this. I went through this pretty quickly, but if this is correct, or it's something I can easily fix if I have something incorrect here, then the next hardest part is going to be getting the actual coding done. Now, part of the coding is not going to be too bad, because on this web page, Paul's 8051 code library is what it's titled. Down at the bottom, there is source code available. So I can come down here and I can look at the assembly. Now, this is assembly for an 8051, which is not what I'm using, so it's a little bit different, but I was looking through it and it doesn't seem like it's going to be that big of a deal. So there's an L call, A call. I think that's an absolute address call or a local type of call. It's basically what address mode I think is essentially that call. And I could be wrong on that, but that's just what I'm guessing as I look at this real quick. And same with things like jump. There's CJNE is probably just some type of a jump if not equal. So I'll just have to look up what that is in the 8051 assembly and then translate all this to x86 assembly. But I don't think that's going to be a big deal. This will give me raw access to the data on the drive if this code works right. It does not implement a file system though. So I'll have to track down how would I get a FAT file system running on my x86 in assembly code. I assume there are some libraries out there to do that, or some samples out there to do that. I can't imagine someone hasn't already written and made available a FAT set of code for this type of thing, but we'll see. If I can start with just getting the raw read from the drive and make sure that that works, that will be a good step, and then I can work on the coding part of it. So that is what I have, basically using this example schematic. Here's another schematic that, again, was for the Z80 kit, but very similar in concept. Between those two schematics, then putting together something that looks like this, and then leveraging this other card for simplicity for now to go ahead and set that right here with the CF card plugged into it, and see if I can make that work. And if that all works out fine, my next step would be, what do I need to do to actually leverage a DMA? That would be great. I am trying to experiment on my motherboard to add, I think I've added everything I need for DMA support, so it'd be great to start to actually try testing that to see if it actually does work, if I can really make it work. And then I think after that, it's the file system stuff I need to get working on. But if I can get, not so worried about DMA, but especially the file system, if I can get that working, that will be a nice step, because then I could load up, I'll call it my operating system on this CF card, and take my flash ROM and try to treat that really truly as just BIOS, and anything that's operating system like, I'll get it moved over to the compact flash, and then I'll figure out how for my BIOS to load files from the compact flash through the FAT file system. So there's a lot of big steps there, a lot of unknowns for me, but I figure I wasn't in the mood to do the breadboarding on this, even though it's really simple. I thought I'll just order up the cards. These cards are less than $2 each, so they're inexpensive, and my updated 286 motherboard is being processed right now, so I just tacked this onto that order. So when I get my motherboard, I'll also receive this card at the same time. If any of you, as always, have experience with this and have anything that I missed or suggestions, let me know. Or definitely a question I have is, well, what would I need to do to get DMA support working? That, of course, means that the drive needs direct access to my bus and not going through a PPI. So I assume that there's a quite a bit different approach to make something like that work. But if anybody has any good examples or feedback on DMA support for an IDE drive, I would love to hear any pointers that you might have. And that's something I'll research more in depth as time permits too.